Imagine asking an AI for the source of a quote. It gives you a book title, a page number, and a calm explanation. Everything sounds polished. Then you check the book, and the quote is not there. The AI did not just make a small mistake, it invented a believable answer. This is what people often call an AI hallucination. It matters because modern AI can sound fluent even when it is wrong. In school, work, law, health, software, and everyday decisions, a smooth answer can feel trustworthy. But fluency is not the same thing as truth. An AI hallucination is when an AI system produces information that is false, unsupported, or misleading, while presenting it as if it were true. It might invent a fact, mix up two real facts, cite a source that does not exist, or describe an event that never happened. The word hallucination can be confusing. The AI is not seeing visions. It is not lying in the human sense. It does not secretly know the truth and choose to hide it. The word is a metaphor for confident output that is disconnected from reliable evidence. The easiest way to begin is with autocomplete. If you type the start of a sentence, your phone predicts the next word. Large language models do something much more powerful, but the basic idea is related. They learn patterns in text, then generate the next likely piece of text. Pattern prediction is not a cheap trick. It can produce essays, summaries, code, plans, and explanations because human language contains a huge amount of structure. If a model has learned many patterns, it can often give useful answers. The problem begins when the pattern sounds right, but is not grounded enough. A language model is usually trained to produce text that fits the context. That can make an answer sound natural, complete, and confident. But the training goal is not the same as checking reality. A sentence can be statistically plausible and still be factually wrong. Think of the student taking an exam they did not fully study for. Sometimes they know the answer. Sometimes they remember part of it. Sometimes they guess in the style of the textbook. A hallucination is like that last case, except the answer may still be written beautifully. One major cause is missing data. If the model has not seen enough reliable information about a topic, it may still try to answer. Instead of saying it does not know, it may fill the empty space with something that matches the style of a real answer. Even when the model has seen relevant information, it does not store knowledge like a library shelf. It learns patterns and relationships. That means details can become blurred. Names, dates, titles, and numbers are especially easy to mix up when the model is generating from memory rather than checking a source. Many hallucinations are not totally random. They are often made from real pieces combined in the wrong way. The AI might connect a real person to the wrong paper, a real company to the wrong product, or a real event to the wrong year. The pieces are familiar, but the connection is false. If this kind of clear explanation helps you understand AI without the hype, consider subscribing. We are building a simple map of the technologies shaping the future, one concept at a time. Now, let us go one layer deeper into why these mistakes can feel so convincing. A common misunderstanding is that confidence means certainty. With AI, confidence can simply be a writing style. The model has learned that direct answers often sound helpful, so it may choose clear wording even when the underlying information is weak. AI assistants are usually tuned to be helpful. That is useful, but it creates tension. If a user asks a question, the assistant is pushed toward answering. A good system should admit uncertainty, but the pressure to be useful can sometimes lead to answers that overreach. Many questions have a familiar shape. A biography has a birth date, career highlights, and major works. A scientific explanation has terms, causes, and effects. A citation has authors, titles, and journals. When details are missing, the model may still produce the expected shape, then fill it with invented content. Fake citations are a classic example. Academic references have a predictable format. Author names, paper titles, journal names, years, and page ranges all follow patterns. If the model is not connected to a verified database, it can create a reference that looks real but points nowhere. Hallucinations can also happen when the prompt is unclear. If you ask about a person with a common name, the model may blend details from different people. If you ask about a product without the version, it may answer using the wrong release. Vague questions create room for wrong assumptions. Another cause is outdated information. A model may know something that was true at one time, but no longer true now. Companies change policies, software changes features, public roles change hands. If the model cannot check current sources, it may give an answer from the past. Some AI systems can use tools such as search, calculators, databases, or code runners. Tools can reduce hallucinations, but they do not remove the risk. The tool may fail, return incomplete information, or be used incorrectly. Then the model may still summarize the result with too much certainty. Many systems use retrieval, which means they search documents and bring back relevant passages before answering. This is powerful, but it depends on finding the right passages. If retrieval grabs the wrong document, misses a key paragraph, or ranks weak evidence too highly, the final answer can still be wrong. A calculator gives exact arithmetic when used correctly, but an AI assistant still has to decide what numbers to enter, what operation to perform, and how to explain the result. If the setup is wrong, the calculation can be perfect and the answer can still be misleading. Think of the model as a map, not the territory itself. A good map helps you navigate, but it can be incomplete, outdated, or simplified. If you treat the map as reality, you can get lost. AI answers are useful guides, but they are not automatically evidence. Small details are hard because they often do not have many repeated patterns. A famous concept may appear in many texts, but a specific page number, exact quote, minor policy detail, or recent update may appear rarely. The model may know the general area, but miss the exact coordinate. It is also important not to call every AI mistake a hallucination. Sometimes the user asks a biased question. Sometimes the source document is wrong. Sometimes the AI follows bad instructions. Hallucination usually means the model generated unsupported content, not simply that the final outcome was undesirable. AI can solve multi-step problems, but long reasoning creates more places for drift. If an early assumption is wrong, later steps may build on it. The final answer can look carefully reasoned while resting on a hidden mistake near the beginning. The biggest danger is not that AI is sometimes wrong. Every tool has limits. The danger is that AI can be wrong in a polished way. A messy answer invites checking. A smooth answer can lower your guard, especially when it matches what you already wanted to hear. Hallucinations are more serious in high-stakes areas. Medical information, legal questions, financial decisions, security advice, and public safety all require stronger verification. AI can help organize questions or explain general concepts, but critical facts should be checked against reliable experts and primary sources. Developers reduce hallucinations in several ways. They connect models to trusted data. They improve training examples. They add tools for search and calculation. They test answers against benchmarks. They also design assistants to say when they are uncertain, instead of forcing a confident response. Grounding means tying an answer to evidence. For example, an AI system might answer using a specific document, database, or search result. Grounding helps because the model is not only relying on memory, it can point back to the material that supports the claim. Grounding reduces risk, but it is not magic. The AI still has to read the source correctly. It has to choose the relevant part. It has to avoid adding unsupported details. Even with sources, you should check whether the answer actually follows from the evidence. Users can reduce hallucinations by asking for uncertainty. You can say, if you are not sure, say so. You can ask for sources. You can provide the document you want summarized. You can ask the AI to separate facts from assumptions. Better prompts cannot guarantee truth, but they help. When the answer matters, ask the model how it would verify the claim. Then check the important parts yourself. Look for primary sources, official documents, original studies, or direct records. AI is useful for finding paths, but verification is what turns an answer into something you can rely on. A healthy way to use AI is to treat it as a drafting and thinking partner. It can brainstorm, explain, compare, and organize. But for precise facts, recent details, and serious decisions, treat the first answer as a starting point. The final responsibility still belongs to the human user. One myth is that hallucinations mean the model is useless. That is too simple. A calculator that cannot write poetry is not useless. A language model that sometimes needs checking can still be valuable. The key is knowing which tasks fit the tool and which tasks require verification. Another myth is that bigger models will automatically eliminate hallucinations. Larger and better trained systems often improve reliability, but the deeper issue remains. Language generation is not the same as truth checking. As long as an AI produces answers from patterns and imperfect evidence, verification still matters. AI hallucinates because it is generating likely answers, not directly experiencing reality. It can lack data, blur details, follow misleading patterns, use tools badly, or overstate weak evidence. The solution is not panic. The solution is AI literacy. Use the tool, but understand the gap between a confident sentence and a verified fact. Now, I want to hear from you. What is the most surprising or suspicious AI answer you have ever seen? Leave a comment with your example, or suggest the next AI concept you want explained in plain English.